Now that we've reviewed lines and talked about how we can have parallel perpendicular lines, an important thing to discuss is how to solve for when two lines intersect. And there's two techniques that are typically used to solve for the intersection between two lines. These techniques are called elimination and substitution. While many students prefer substitution, it is very important to become familiar with elimination, as this will be very useful when you take linear algebra or work with matrices in the future. Row operations and Gaussian elimination, which is a technique you will eventually learn in linear algebra, is the generalization of the elimination technique. Now, we're going to first review our steps for substitution. Suppose you have two lines, L1 and L2. If possible, isolate for y for both lines. When it is not possible to isolate for y, isolate for x. If both lines isolate for y, or both isolate for x, set them equal to each other. Otherwise, skip this step. When you use your equality to solve for x, if no solution exists, then the lines are parallel and do not cross. If the solution exists for every x value, then the lines are parallel and equal at every point on the line. If only one solution exists, then use x and use x and one of your original equations of the line to solve for y. This point xy will be your point of intersection. So let's practice this to solve for points in the line, and we're going to do this using substitution. So my first step is to isolate for y. Isolating for y gives y equals 3x minus 2 and y equals 2x minus 3. Setting them equal to each other gives 3x minus 2 equals 2x minus 3. Isolating for x gives x equals minus 1. Substituting x equals minus 1 into y equals 3x minus 2 gives y equals 3 minus 1 minus 2, which equals minus 5. Thus, the lines cross at minus 1, minus 5. Instead of writing out what the steps are for each of the following, I will just complete it. We now have the lines y equals 3x minus 2 and 6x minus 2y equals 4. Well, this implies that we're isolating for y gives y equals 3x minus 2. And here we get y equals 3x minus 2. Setting them equal to each other, 3x minus 2 equals 3x minus 2 implies that 0 equals 0 for all x. Now, this is true for every value of x. Thus, the lines are parallel and cross at every point. Our next set of lines are y equals 3x minus 2 and y equals and 6x minus 2y equals 5. Well, this gives y equals 3x minus 2 and y equals 3x minus 5 over 2. Setting them equal, 3x minus 2 equals 3x minus 5 over 2, which implies when we subtract 3x from both sides, minus 2 equals minus 5 over 2. This is never true. Thus, the lines are parallel and never cross. Now for step 4, or for our fourth example, we have y equals 3x minus 2 and 4x plus 8 equals 0. Well, this implies that y equals 3x minus 2, and here we can't isolate for y, so we isolate for x. X equals minus 2. We take that minus 2 and we plug it in, so y equals 3 minus 2 equals minus 8. Thus, the lines cross at minus 2, minus 8. We're now going to look at our steps for elimination. Now, elimination, what we're going to do is we start by converting both expressions into standard form. We add a multiple of the top line to both. We add a multiple of the top line to the second line to make one of the variables equal to 0. We solve the resulting inequality. If no solution exists, then they are parallel and never cross. If an infinite number of solutions exist, then the lines are parallel and cross at every point along the line. If no solution exists, I just repeated that same expression again. If one solution exists, then use this solution and the first line to solve for the point of intersection. So we have our two lines, y equals 3x minus 2 and 4x minus 2y equals minus 6 equals 0. Converting this into standard form gives us 3x plus y plus 2 equals 0. Now, if we take, well, this is our line 1, and our line 2 is going to be (4x minus 2y minus 6 equals 0). We can take our line 2, we're going to add minus 2 line 1, and this gives minus 2x plus 0y minus 2 equals 0. Isolating for x gives x equals minus 1. Now, substituting this back in into L1 gives 3 minus 1 plus y plus 2 equals 0. or y equals oh, I just realized I made a minus sign there. Converting to standard form gives 3x minus y minus 2 equals 0 and 4x minus 2y minus 6 equals 0. L1 plus negative 2 L or L2 plus negative 2 L1 gives the expression minus 2x plus 0y minus 2 equals 0. And I've eliminated the y here. Now we can eliminate either the x or the y. It doesn't matter. And now isolating for x, gives x equals minus 1. Substituting into L1 gives, remember this is L1 and this is L2, gives 3 minus 1 plus y minus 2 equals 0, which implies that y equals minus 5. Thus, the points cross at minus 1, minus 5. Now there's 3 more lines here, and there's an opportunity to practice those 3 more lines. I highly encourage you to practice the elimination. We know what the solutions are because they're the same lines as the previous example, but I encourage you to practice.